Hi everyone, my name is Shaul Ashkenazi and I'm a PhD researcher at the University of Glasgow. In this presentation, I will be discussing multilingual social robots supporting newcomers with bureaucratic challenges using conversational AI. Social robots are leaving the controlled environment of the lab and being increasingly deployed in public spaces, where they take on the role of a receptionist, a greeter in a museum, or at the mall, and even as a barista. While most social robots use the dominant language of the country where they were developed, and often use standard accents such as General American, the newly arrived are often not fluent in the spoken host language. Prior research on second language interaction and access to services has found that clients prefer communicating in their native language, as it allows them to express emotions, articulate problems, and reflect on situations more thoroughly, showing the necessity of making information available in a native language. I would like to focus on two use cases where we developed and deployed social robots in public spaces, interacting in the user's native language. I will focus on the solution architecture. The first was aimed at international students at the University of Glasgow's Student Support Centre, developed in collaboration with the support staff. The other was aimed at refugees and asylum seekers in a Scottish charity's drop-in service, again with the full support and involvement of the staff. In both use cases, the robots were placed in a space where newcomers would go when they seek help and support. The robot is there to empower the staff and not to replace them. When the robot cannot help, the newcomers will get support from the human staff. International students in the UK often struggle with interactions in English, especially on their first days in the country. They experience both a culture shock and a language shock. Students from China report that they do not feel belong or supported in UK universities. We deployed our multilingual robot in the University Student Support Center in order to bridge that gap. The robot was programmed to help with common support tasks in Chinese Mandarin as well as in modern Standard Arabic and English. This project was designed and developed 2 years ago and based on a state machine. The interaction starts with choosing a language on the tablet. The robot describes the different topics they can help with. The user then asks a question, the LLM does the classification, and goes through the state of the state machine until the user receives an answer as a QR code they can scan with the relevant information. For example, if the user asks for directions for the library, the LLM classifies the request as general. A QR code for the campus map appears on the tablet. The user scans the code, says thank you, and the conversation ends. I'll now show you a short interaction in Chinese Mandarin on a different topic.
嗨，我是学生支持机器人。你可以问我关于校园路线、官方文件、议会免税和经济援助的问题。今天需要什么帮助吗？
议会免税。
您住在格拉斯哥市议会还是其他地方当局？
我住在格拉斯哥市议会。
如需更多说明，请扫描下面的二维码。您扫描过二维码了吗？
我扫描过二维码了。
我还能帮你什么忙吗？
可以了，谢谢。
如果您能通过点击平板电脑对我们的对话进行评分，我将不胜感激。谢谢您，祝您有愉快的一天。
The first use case focused on international students, a population that chose actively to come to the UK. The second use case is focused on a displaced population, refugees and asylum seekers. In order to understand this population better, we conducted 2 focus groups with Syrian refugees, and through thematic analysis, we identified that their biggest concerns were housing and registration to English courses. Unfortunately, it was beyond our capabilities to help, and together with the charity staff, we explored other areas where the robot could prove useful. Another big concern which they reported was lack of access to information. Together with the charity staff, we decided that the robot will give information about services in their neighborhoods, such as food hubs, where they can get food for free or at a discount. We created online resources and generated maps with the relevant locations. This project was developed recently and based on LLM and drug. Again, the interaction starts with choosing a language on the tablet. The robot describes the different topics they can help with. The user then asks a question. The LLM does the classification. But now, the conversation is open and natural with the use of LLM and drug. The end goal of the conversation is given information. The user asks the robot what's available in their neighborhood and supplies the first part of their postcode. A QR code appears on the tablet with a map with short descriptions and Google Map links. The user scans the code, says thank you, and the conversation is over. In conclusion, the key takeaways are: architecture evolves with model reliability. Early systems needed tighter control, such as a state machine. Nowadays, improved reliability allows flexible LLM-centric designs with minimal deterministic logic. Knowledge integration enables adaptability. When information is static, fixed flows work. For dynamic, evolving domains, LLM and drug provide scalable, accurate, and user-specific responses. I would like to thank my collaborators and to thank you all for listening. I'm happy to take any questions.